Transformations on the coordinate plane. If you watch the last video and the one before that, there's not a whole lot of new information here, but a little bit more practice and then a closer look at dilation or scale factor. Which transformation creates a similar but not congruent figure? So in the last video, we talked about 3 transformations that are rigid transformations, and they have that name because the shape doesn't change size, right? Same shape, same size when you do a rotation, a reflection, or a translation. But when you do a dilation, that means you're going to make something larger or smaller. You are keeping the shape and the angles the same, but you're changing the side length. So what you're creating is a similar figure, but not congruent. Okay, so a dilation creates a similar figure. Which pair of transformations has been performed on the triangle on the left to form the triangle on the right? Okay, and we're given down below that 2 similar triangles are shown in the grid above. So we've got 2 similar triangles. What pair of transformations has been done to the triangle on the left? Well, first, let's look at the size. The base of this triangle is 1, and the height is also 1. The base of this triangle is 4, and the height is also 4. So it appears as though each of the lengths is 4 times as long. That would mean that some sort of scale factor was applied here, and that scale factor would have to have been 4. Right, so we have a scale factor of 4. Then the triangle also appears to be backwards, right? The right angle in the original small triangle is on the right side, and here it's on the left side. So that triangle appears to have been flipped. So if we were to flip this small triangle about the y-axis, think about where it would land. Well, it would land right here, right? If we were to flip it over the y-axis and do nothing else, that's where the triangle would be. So now you might be thinking, oh, so a translation, right? But that's the thing about dilations. When you dilate something from the origin, 0, 0, then what you're doing is you're scaling not only the length of the side, but you're scaling the distance to the figure. So let me show you what I mean. Originally, to get from the origin to, let's say, this right angle point, it was 2, right? Now, to get from the origin to that right angle point, it's 8. That was scaled up by a distance or by a scale factor of 4, right? The original distance was 2. Now the new distance is 8. The same thing would happen if we were to measure this distance from the origin to the top point, right? And then from the origin to the new top point, the larger one would be 4 times the smaller one. And you guessed it, same thing would happen if we did it to that last remaining point. The distance from 0, 0 to this point, and then the distance from 0, 0 to this point, the new one is 4 times the distance of the original. So if we look at the distance, let's just look at that first point so that it's a little less confusing, because now we've got all these segments on here and I don't want it to get muddled, right? If we just look at this very first one here, right? our original distance from 0, 0 to that right angle point was 2. Now that distance is 8. That fits our scale factor. So what that tells me is that there's no translation happening here. It's just a dilation after that reflection, right? So which pair of transformations would take us from the triangle on the left to the triangle on the right? It would be a reflection about, oops, sorry, forgot my C there. Reflect about the y-axis, and then a dilation with a scale factor of 4. Those would be the two transformations that would take us from that little triangle on the left to the much larger triangle on the right. And for this question, we're given two similar triangles, right? We're told that they're similar. Triangle PQR is transformed to similar triangle P prime, Q prime, R prime above. What is the scale factor of dilation? So just like in the last problem, we could look at the lengths of the triangle sides, right? Like in this, these are right triangles. So we could look at the leg lengths. We could also look at distance from the origin. Now, because distance from the origin is diagonal here, that's going to be harder to figure out because we'd actually have to use something called the distance formula. So instead, we can just look at the side lengths. Here, my original side length is 3. This is the base of my triangle. My original height is 2. In the new triangle, my base is now 6, and my new height is 4. So how do I get from 3 to 6 or from 2 to 4? I double. So that means that my scale factor here must have been 2. It's really important when you're looking at scale factor to make sure you know which triangle was the original. Remember, the one without the little apostrophes is the original triangle. The one that has the little apostrophes is what we call the image, right? It's the new triangle that was created from the transformation.